Hello, we're going to go through a couple of problems using U-substitution for evaluating integrals. So here we have the integral of e to the ln x over x dx. Now when we use U-substitution, we need to figure out what our u should be. If this were just e to the u, we could certainly integrate it. So let's see if that's going to work if we let u equal ln x. Now remember, whatever we choose for u to be, we need to make sure that the derivative of that function is also somewhere in our integrand. So when we find the derivative of u with respect to x, we know that the derivative of ln of x is 1 over x. So that is also in our integrand if we think of this as 1 over x. So if we solve this for du, we see that that is equal to 1 over x dx. Okay, so that means when we do our U-substitution, we can replace everything in our integrand in terms of u. So we'll have the integral of e to the u du. Okay, so that replaces e to the ln of x is replaced with e to the u, and the 1 over x dx was replaced with du. Okay, so now we can evaluate this integral. We know that the integral of e to the u is also e to the u plus any constant, so we'll say plus c. Okay, now our final step here is that we want our answer to be in terms of x, not in terms of u, so we can go ahead and plug back in what u equals in terms of x, and that was ln x, and then we have our plus c. So that's our integral, or antiderivative. Now remember that we can always check our answer when we're integrating. So to check our answer, we want to take the derivative of our answer using the chain rule here. So the derivative of e to the ln of x is going to be e to the ln of x times the derivative of ln x, which is 1 over x, and then plus 0, because the derivative of any constant is 0. So this simplifies to e to the ln x over x, which is exactly what we started out with as our integrand. Okay, so let's look at another one here. So we have the integral of 5 cosine x over the square root of sine x dx. Okay, so the first thing we should do is see that there's a constant there that we can take out in front. So let's take the 5 out in front, just to make it a little bit easier. So we'll have 5 times the integral of cosine x times the square root of sine x dx. Okay, so when we figure out what to do for our u substitution here, remember that we can integrate if we have a u in the denominator, because we can always bring that up to the numerator, but we don't want to have a du in the denominator. So let's see if it'll work if we try to let u equal sine x. Okay, because then we'll have a square root of u in the denominator, which we can certainly deal with. Okay, so then when we find our du dx, the derivative of sine x with respect to x is cosine x, which means that du is going to be cosine x dx, which is nice because now we can replace this entire numerator of our original integrand with du. So when we do our substitution, we still have that 5 out in front. So we have 5 times the integral of, instead of cosine x dx, we can replace that with a du over, in the denominator, instead of square root of sine x, we can say square root of u, since we let u equal sine x. Okay, so now this is something that we can integrate. So let's bring that u up to the numerator by writing it as u to the negative 1/2 power du. Okay, so when we integrate that, we can use the power rule for anti-differentiation. So we have 5 times u to the, so we have negative 1/2. We want to add 1 to our exponent, so negative 1/2 plus 1 is positive 1/2. And now we divide by our new exponent. Dividing by 1/2 is the same thing as multiplying by 2, and then we have plus c, plus any constant. Okay, so this means we have 10 times the square root of u plus c. Okay, last step is to plug back in what u is in terms of x, and remember that we said u equals sine x. So our integral is 10 times the square root of sine x plus a constant. Okay, again, we can check our answer using the chain rule. Do that over here. So to check this, we find the derivative of our answer and make sure we get exactly what we started with here in the integrand. So to check our answer, here's our derivative. We have 10 times derivative of root sine x is 1/2 times sine x to the negative 1/2 power. We're subtracting 1 from the exponent now because we're differentiating, times the derivative of our inside function. Derivative of sine x is cosine x, and then plus 0 because that's the derivative of any constant. Okay, so now to simplify this, 10 times 1/2 is 5, left with a cosine x in the numerator, and then we'll move that sine x to the negative 1/2 down to the denominator, and that's the same thing as root sine x in the denominator, plus 0, so that is exactly what we started with, what we were trying to integrate, so we know that we have the right answer.